Hello, everyone. Welcome back to another video with us here at LMD and STEM Academy. In this video, we will be working through the June 2021 Unit 2 Paper 2, and we'll be working on Question 1, Part C. So the first part says compound Q is an acyclic hydrocarbon of molecular formula C4H8. Right? And so when we generally see molecular formulas, one of the first things that we want to do is just kind of immediately connect in our heads what homologous series that belongs to. And I can see right away that that's an alkene, right? That's an alkene because it has the general formula CnH2n. And so the other thing that's key to note here is that they said it's an acyclic hydrocarbon, so we know it's just going to be a straight chain one, right? There are no cycles in it, right? So it's not a cyclic thing. So it's a straight chain one. Okay. All right. So that's compound Q. So we know quite a lot about compound Q so far. So let's see what else is being asked of us now. So they're asking us to write a displayed structural formula of two isomers of Q. Okay. So again, here's my little hint to myself, my little note to myself. I know it's an alkene. So I know there has to be a double bond in it, and there are 4 carbons in it. So let's start by drawing isomer 1. Now, the first isomer that we generally tend to put down, if they don't give us definitively a name for the compound along with the formula, we're just going to write the most common form of what we think this could be. So the most straight chain form. Okay? And so that would be here. It would be C, double bond, C, and then all of the other 2 are single bonds, right? And so I just put my double bond after the first carbon, the most simplest form of it, right? And I know there has to be 8 hydrogens, so I'm going to start populating with my hydrogens. Put one here, and put one here, and then here, and then here, 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 and here. All right, so those are my 8 hydrogens that I populated with. Now, they said 2 isomers of Q. So I could draw another isomer of this. And in fact, I'm just going to go ahead and do a positional isomer where the double bond is in a different location. So I'm going to put the double bond right here, okay? And so when I do that, this is what I'm going to get. I'm going to have C, single bond C, double bond C, C, and then I'm just going to populate out with the rest of them with H's now. So that will have an H on it. That will have an H on it. That will have an H there. One more here. All right, so that's good, right? All right, and so we have just drawn the displayed structural formula of 2 isomers. And so when they say displayed, again, you want to show all the bonds and all the atoms that are present. And so that's what we've done. And so this one, if we were naming it, let's just name it, just so we know what we've drawn, right? This one here is but1-ene. It's 4 carbons. It has a double bond on the first carbon. So that one is but1-ene. And then this one, where the double bond is on the second carbon, would be but2-ene. Okay? So that's what we just drew. And those are 2 isomers of Q, which has a formula C4H8. All right. So moving right along now, let's see what else is being asked. So to state whether compound Q is geometric or cis-trans isomerism. And so we are going to go ahead and say, yes, compound Q exhibits geometric or cis-trans isomerism. And the way that we kind of arrived at this, we'll state our reasons in more detail later on, but the way that we arrived at it is that whenever we have compounds where there are carbon-carbon double bonds in it, because there's restricted rotation about that double bond, we can't just flip it over. We're going to get what we call geometric isomers, okay? So keep that in mind. Like whenever you have a double bond, there exists the possibility that you could have geometric or cis-trans isomerism in that compound. Okay, so that's how we arrived at that yes being our answer there. So let us explain a little bit further now in the other part of this question. So this part C is asking us to state 2 reasons why we said, right, it would have geometric isomerism. And so the two reasons are, one, as I said, due to the presence of the carbon-carbon double bond, which has restricted rotation, we can't just rotate and get a different molecule. You know, the substituents, wherever they are going to be locked into place. Like we can't move them around, and that's why we get geometric isomerism. So that's the first reason. And the second reason is that in isomer 2, right? Let's bring back isomer 2 so you can see isomer 2. Here's isomer 2. And what we're saying is that in isomer 2, we see that there are two methyl substituents on the carbon-carbon double bond. So like, look at this carbon-carbon double bond, right? You see that you have a hydrogen here, but then you have a methyl substituent here. And then when you look at this carbon-carbon double bond, you have a hydrogen same way, but then you also have a methyl substituent. So these methyl substituents, and I'm going to show real quick because I think it's important to just visualize it, right? We could have those methyl substituents being either on the same side of the carbon-carbon double bond. So I could have it being up here, positioned up there. And that would be cis but 2E. Or I could have them, right, the methyl substituents being on opposite sides of the carbon-carbon double bond. So I could have one right there, and then I could have another one down there. So you see how they're like transverse, like opposite? All right. So, and then I'll put back the H and put back the H. So when it's transverse like that or on opposite sides, we say that that's a trans isomer. So that's trans but-2-ene. Okay, so yes, so the methyl substituents could either be on the same side of the carbon-carbon double bond, like up here, or they could be on opposite sides like I've shown. And these guys, right, would constitute what we call geometric isomers, okay? And so those are the two reasons there as to why we could say, yeah, there's gonna be geometric isomers from compound Q, okay? All right, so let's keep going forward now. So let's clear this. Definitely give this video a like, subscribe to the channel, and if you look on your left here, you'll see the next video up. And if you look on the right here, you'll find our Module 1 playlist with tons of interesting content that will be helpful in getting you prepared for your exam. So thanks for watching, and we'll see you in our next video.